All right, calculus students, we are continuing our study of chapter 3.4, rate of change, and we are on 3.4.2. We're going to look at a projectile motion problem. If you watched the previous video, it was also a rate of change problem, but it was the particle problem with an object moving forward and backwards. So this time around, we're going to talk about an object that is thrown up in the air. So let's make a little story here. We have Johnny. Johnny is going to throw a ball up from the ground to his or her friend standing on the third floor, but misjudges the target and the object hits the ground. It was launched upward with a velocity of 64 feet per second. Its height is given in this function. Let's analyze the throw. And when I say use proper notation, I mean if we're using the S function, refer to it as S of t. If you're using the derivative, refer to it as S prime of t or V of t. And then let's include units on all of our answers. All right, what is the object's height after 1 second? Well, this is a height formula based on the story up here. So that means we're going to substitute 1 in here. So 64 times 1 minus 16 times 1 squared. So that would be 48, and that is, we are in feet here. So that would be 48 feet. Okay, what is the object's velocity after 1 second? Well, we need a velocity formula. So our height formula represents the original function. Its first derivative would represent our velocity. So we're going to find the first derivative using our power rule. So 64t becomes 64 minus 2 times 16 is 32t. So we now have a velocity function. And we are finding the velocity after 1 second, so we're going to substitute 1 in here. So we're left with 32. This is a velocity unit, and our change in y of velocity is like slope of the tangent line. Our change in y is measured in feet. Our change in time is measured in seconds, so this would be a feet per second measurement. Part C, how long does it take for velocity to reach 8 feet per second? So we are given velocity. So I'm not going to use the height formula. I'm going to use my velocity formula. And I am going to be substituting 8 in, but not for time. This is a velocity metric. So I'm going to substitute 8 in for V. 8 minus 64 is negative 56. Divided by negative 32. Is going to leave us with, we can divide by 8, so that would be 7/4 seconds, or 1.75 seconds if you prefer decimals. So that is the moment when the ball reaches 8 feet per second. When does the ball hit, I'm sorry, that's the moment when the velocity reaches 8 feet per second, excuse me. When does the ball hit the ground? Okay, so when you talk about the ball hitting the ground, if you think about this function, it is a parabolic behavior. It's a quadratic function. If I tried to sketch it, my input is time, my output is position, which we know is really height in this case, and that is in feet, and my time is in seconds. Okay, so we're talking about a parabola that's opening down. So we're going to have something like this. As time goes on, the height increases, and then eventually it hits the ground. So the question is, when does the ball hit the ground? Well, what do I know about that moment when it hits the ground? I know that my height is 0, which means I know that my S of t is going to be equal to 0. So what we're going to do, we are going to set S of t equal to 0. So I'm going to take my original function up here. S of t equals 64t minus 16t squared, and I am going to set this equal to 0. And this is a quadratic, but I'm going to solve by factoring. So we can factor 16t out, and I'm left with 4 minus t. Set 16t equal to 0, I have t equals 0. Set 4 minus t equal to 0, I have t equals 4. So I have 2 points when the ball is at a height of 0. Clearly, the first one is the moment when I launched the object up. So my second one is at time equals 4. So that is actually when the ball hits the ground. So time equals 4. Don't forget your unit. Let's squeeze in a little s for seconds. Next question, when does the ball reach its maximum height? So there's two ways you could answer this. The first way is this is a parabola. This is a quadratic function, and we know a parabola is symmetrical in nature. Takes the same amount of time to get to the top as it does to get to the bottom due to the force of gravity. Once you launch that object, the only thing pulling that down is gravity. So when we're assuming there's no wind resistance in this problem. So if this is happening right in the middle of my parabola, you can just take the center of 0 and 4, which would be 2. So when does the ball reach its maximum height? Time equals 2. However, sometimes you're not working with a quadratic function when you're asked a question like this. So if, for example, it could have been a particle problem like the one that we looked at in the previous video. So when does it reach its maximum height? Well, that moment when it reaches its maximum height, that object, as it shoots up into the air and comes back down, that object is going to have a moment in time where it has 0 velocity. In fact, if that was a bowling ball and somebody tossed a bowling ball up in the air and it was going to hit you, that's when you would want it to hit you, right at the top when it has 0 velocity. So I know that I'm going to set my velocity equal to 0 to solve this algebraically. Another way of looking at it is if you go back to your graph over here, if we're looking for the maximum of this parabola, at this highest point, my tangent line would actually be horizontal. And what is the slope of a horizontal line? 0. And slope is the same of the tangent line is the same as instantaneous velocity, which is 0. So whichever way you look at it, we are going to take our velocity formula right here, and we are going to set that equal to 0. And solve for t. Slide your 32t over to the other side, divide through by 32, we get time equals 2 seconds. So that's when it hits its maximum height. Next question, what is the maximum height of the ball? Well, we now know when it hits the maximum height. I just need to find what the actual height is. So we can go all the way back to our original function. This was a formula for height. So S of t equals 64t minus 16t squared. We're going to substitute a 2 in here. So we have 128 minus 4 times 16 is 64. So we have a height of 64 and we are in feet. So 64 feet is actually the highest height that we reach. So if we were going back to that little picture way over here, this highest height here would be 64. Okay, last question. We estimate the height is 30 feet from the ground. Oh, there's a couple words missing. We estimate the height of the friend up on the second floor or third floor is 30 feet from the ground. What is the velocity of the ball when it is 30 feet in the air on the way up and on the way down? So if you go back to your picture, we're saying, okay, here's 64 feet. Wherever 30 feet is, we want to find at what point we hit 30 feet. And if we can find when it hits 30 feet, then we can find what the velocity of the ball is at 30 feet. So what I'm going to do is work with my height formula. And I'm going to start by forcing my height to be 30 feet high. Again, we're looking for the time values when the height or when S of t is 30. So I'm going to substitute 30 in for S. This is my goal here. That's going to give me a time value, and then I'm going to use that to find velocity. So I'm going to substitute 30 in for S over here. And this is a quadratic. I prefer my, obviously all my terms are going to be on the same side. I prefer my leading term to be positive, so I'm going to move everything over to the left. So we have 16t squared minus 64t plus 30 equals 0. And now, if you want to clean this up a little bit, we could divide by 2. So we'd have 8t squared minus 32t plus 15. Can't clean it up anymore. You can try to factor that if you want, but if it's going to take you longer than 20 seconds to factor, I would cut your losses there, and I would instead go with the quadratic formula. It's been a while since we used that, so let's remind ourselves. So x equals, or in this case t, equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, this is going to give us two answers. So I'm going to come over here, and we're going to have t equals, and a is 8, b is negative 32, c is 15. Or if you hadn't divided by 2, you would be using the previous version, the 16, the negative 64, and the 30. So negative b, so negative 32 plus or minus the square root of negative 32 squared minus 4 times a is 8 times c is 15. And that is all over 2 times a, which is 8. And at this point, you are absolutely going to go to your calculator. Don't calculate any of that by hand. Not worth your time. So let's clear out what we have in here. And we're going to go to the alpha. I'm going to use my fraction key. So alpha y equals, you can certainly clean this up along the way. I'm actually going to type it in exactly as I see it. So negative 32, and I'm just going to find the plus version for right now. Remember, there's no plus or minus key. You have to input this twice in the calculator. We have negative 32 squared minus 4 times 8 times 15. Whoops. And that is all over 2 times 8. And our first answer that we get is 3.46 seconds. And then I'm going to go ahead and find my second answer, which is the same exact quadratic formula, but it's the minus version instead. So, well, it would help to change the plus sign to a minus. So I'm just going to override that plus sign with the minus key. And my second time value is 0.542. Okay, so did I answer the question? Not yet. What is the velocity of the ball when it's 30 feet in the air on the way up and on the way down? So I just found the two time values. So the earlier time value is on the way up. The later time value is on the way down. So this is that 0.542 number. This is that 3.46 number. But I really want to find the velocity. So I'm going to go back up here. I'm going to grab my velocity formula and find both of those. Remember, this is on the way up. This is on the way down. So we're going to find velocity at 3.46. So 64 minus 32 times 3.46. And then I'll go ahead and set it this one as well. So this is velocity at 0.542 seconds, which would be 64 minus 32 times 0.542. Okay, when you are doing this on your calculator, do not use those rounded numbers. I know it's very tempting to do that, but don't. So we're going to take 64 minus 32 times, and I'm going to go up and grab that exact answer. When you are being asked to round to 3 significant figures, then you really need to take your answer out to 6 significant figures if you're going to not use the exact answer. If you are an AP student or a calculus honors student, we're going 3 decimal places usually there. And you want to go more than 3 decimal places unless you're going up and grabbing the exact answer in your calculator, which is what I am going to do. So I am left with the velocity at time equals 3.46 is negative 46.6, and that is feet per second. And then I'm going to find the time at 0.542. But I'm going to go ahead and grab that from up here. And I am left with 46.6. How about that? Is that a coincidence that we would be left with the exact same answer, a positive and a negative version? Well, coincidences like that don't happen very often in math. If we slide back up here, what did we just find? We just found the velocity on the way up at this moment and the velocity on the way down at this moment. And what is another name for velocity? Instantaneous slope of the tangent line, or instantaneous velocity. Slope of the tangent line, which is also our first derivative, right? If you're looking at a function, f prime of x, all different ways to say the same thing. The slope of the tangent line, there's my tangent line, it's the slope of that line here. On the other side, that tangent line has the exact same slope. It's just that the object is moving up versus moving down, or your slope is positive versus moving negative. But we know that it's the same absolute value of a number because parabolas are symmetrical in nature. So if we were an equal distance away from that highest point, I would expect that slope to be a positive version, this slope to be a negative version. Okay, thank you so much for listening. That concludes our lesson on 3.4. Good luck to you.